According to National Electrical Code Section 384.26 AN, a metal raceway must have sufficient area for the conductors within it. The amount of space required depends on the number and size of the conductors. National Electrical Code Table 384.16 provides the minimum cross-sectional area of raceways for different numbers of conductors. For 32 American wire gauge conductors, which are typical for low-voltage devices, the minimum cross-sectional area for a raceway is 0.60 square inches. In your example, the cross-sectional area of the raceway, determined by multiplying its width by its height, is 3.25 inches times 8 inches, which equals 26 square inches. Therefore, the raceway, in this case, has sufficient cross-sectional area for 32 conductors based on those parameters. The National Electrical Code does not specify a maximum number of receptacles that can be installed in a raceway. However, as a general rule, it is not recommended to overload a raceway with too many receptacles. Overloading a raceway can lead to, firstly, excessive heat buildup, secondly, an increased risk of electrical fires, and thirdly, damage to conductors and equipment. For a 48-inch raceway, 32 receptacles may be excessive, especially if they are all used simultaneously. It is recommended to consult with an electrician to determine the maximum number of receptacles that can be safely installed in your raceway based on the specific conductors and equipment being used. Some more details about raceways and conductors can be explored. The National Electrical Code provides specific guidelines for the installation of electrical systems. These guidelines ensure safety and proper functioning. When dealing with metal raceways and conductors, several factors must be considered to remain compliant with the National Electrical Code. Here are some key aspects to consider when designing and installing a metal raceway system. Firstly, conductor fill. The National Electrical Code specifies the maximum number of conductors allowed in a raceway based on the raceway's size and the conductor's size. This is known as the conductor fill. Exceeding the conductor fill can lead to overheating and insulation damage. Secondly, directing factors. When multiple current-carrying conductors are installed in a raceway, the ampacity of each conductor must be reduced, a process called directing. This is because the heat generated by the conductors can raise the temperature inside the raceway, potentially damaging the insulation. National Electrical Code Table 310.15 provides the adjustment factors for directing conductors based on the number of current-carrying conductors in a raceway. Thirdly, grounding. Metal raceways must be properly grounded to provide a safe path for fault current. This is typically achieved by bonding the raceway to the equipment grounding conductor. Fourthly, support. Raceways must be properly supported to prevent sagging or damage. The National Electrical Code specifies the maximum distance between supports for different types of raceways. Fifthly, box fill. When conductors enter a junction box or enclosure, the box must be large enough to accommodate the conductors and any devices installed in the box. The National Electrical Code specifies the minimum box size based on the number and size of conductors entering the box. Sixthly, bending radius. When bending conductors, it is important to maintain the minimum bending radius specified by the National Electrical Code. This prevents damage to the conductor insulation. Seventhly, protection from physical damage. Raceways must be protected from physical damage. This can be achieved by installing the raceway in a protected location or by using a raceway that is designed to withstand physical damage. Eighthly, wet locations. When installing raceways in wet locations, such as outdoors or in damp environments, it is important to use raceways and fittings that are listed for wet locations. These raceways and fittings are designed to prevent water from entering the raceway and damaging the conductors. Ninthly, corrosive environments. In corrosive environments such as chemical plants or coastal areas, it is important to use raceways and fittings that are made of corrosion-resistant materials. These materials can withstand the corrosive elements in the environment and prevent the raceway from deteriorating. Tenthly, National Electrical Code compliance. It is important to consult the National Electrical Code and local electrical codes to ensure that the installation meets all applicable requirements. These codes provide detailed guidelines for the safe and proper installation of electrical systems. When determining the acceptability and the number of receptacles for a metal raceway, several factors come into play. Firstly, National Electrical Code compliance. Ensuring the raceway installation adheres to the National Electrical Code standards is paramount for safety and regulatory compliance. Secondly, conductor fill. Calculating the correct conductor fill to prevent overcrowding and overheating within the raceway is crucial. Thirdly, receptacle load. Assessing the load each receptacle will handle and its impact on the raceway's overall capacity is vital. Fourthly, heat dissipation. Evaluating the raceway's ability to dissipate heat generated by conductors and receptacles to avoid thermal issues is a must. Fifthly, safety margins. Incorporating safety margins in calculations to account for potential future increases in load or unforeseen circumstances is a good practice. Sixthly, professional consultation. Consulting with a qualified electrician or electrical engineer for guidance and approval, especially for complex or critical installations, is advised. Considering these aspects helps ensure a safe, efficient, and code-compliant metal raceway installation with an appropriate number of receptacles. The National Electrical Code Section 384.26a addresses the requirements for the size of raceways, which must be sufficient to accommodate the conductors installed within them. The necessary space depends on the number and size of the conductors. National Electrical Code Table 384.16 provides the minimum cross-sectional area of raceways for varying numbers of conductors. When considering the number of receptacles in a raceway, the National Electrical Code does not specify a maximum number. However, overloading the raceway should be avoided to prevent excessive heat buildup, increased risk of electrical fires, and damage to conductors and equipment. Consulting with an electrician is recommended to determine the safe number of receptacles based on the specific conductors and equipment used. Additional factors to consider include conductor fill, dirting factors, grounding, support, box fill, bending radius, protection from physical damage, wet locations, and corrosive environments. Adhering to the National Electrical Code and local electrical codes ensures a safe and compliant installation. The calculation of conductor fill involves determining the total cross-sectional area of all conductors within the raceway and comparing it to the raceway's internal area. The conductor fill should not exceed the maximum allowable percentage specified in the National Electrical Code. Dirting factors are applied when multiple current-carrying conductors are installed in a raceway. The ampacity of each conductor must be reduced to prevent overheating. National Electrical Code Table 310.15 provides the adjustment factors for dirting conductors based on the number of current-carrying conductors in a raceway. Grounding is essential for metal raceways to provide a safe path for fault current. The raceway should be bonded to the equipment grounding conductor to ensure proper grounding. The support of raceways is crucial to prevent sagging or damage. The National Electrical Code specifies the maximum distance between supports for different types of raceways. Box fill refers to the space within a junction box or enclosure. The box must be large enough to accommodate the conductors and any devices installed in the box. The National Electrical Code specifies the minimum box size based on the number and size of conductors entering the box. The bending radius of conductors is important to maintain to prevent damage to the conductor insulation. The National Electrical Code specifies the minimum bending radius for different types of conductors. Protection from physical damage is necessary to prevent damage to raceways. Raceways should be installed in protected locations or use raceways designed to withstand physical damage. Wet locations require the use of raceways and fittings listed for wet locations to prevent water from entering the raceway and damaging the conductors. Corrosive environments necessitate the use of raceways and fittings made of corrosion-resistant materials to withstand the corrosive elements in the environment and prevent the raceway from deteriorating. Compliance with the National Electrical Code and local electrical codes is essential to ensure the safe and proper installation of electrical systems. Consulting with a qualified electrician or electrical engineer can provide guidance and approval for complex or critical installations. By considering these factors, a safe, efficient, and code-compliant metal raceway installation with an appropriate number of receptacles can be achieved. In summary, when determining the acceptability and number of receptacles for a metal raceway, consider National Electrical Code compliance, conductor fill, receptacle load, heat dissipation, safety margins, and professional consultation. These factors will ensure a safe and efficient electrical system. Remember to consult the National Electrical Code and local electrical codes for specific requirements. Also, it is always a good idea to consult with a qualified electrician or electrical engineer for guidance and approval.